Imagine a paradise so breathtaking it seems untouched by danger, a place where emerald cliffs rise above sapphire seas and sunlight dances on the surface of a tranquil lagoon. Yet beneath this serene beauty, nature conceals hazards that are as real as they are invisible. In these idyllic settings, peril often wears a mask of tranquility. Take the ocean, for example. Its crystal-clear waters may look inviting, but beneath the surface a nearly invisible jellyfish drifts, its tentacles armed with potent venom. A stonefish, perfectly camouflaged among the coral, waits motionless, its spines capable of delivering a sting more painful than any predator's bite. Even the gentle rhythm of the waves can hide a deadly rip current, ready to pull the unwary out to sea in seconds. On land, paradise is no less deceptive. A volcanic crater may appear dormant, but it can release invisible gases like carbon dioxide, which pool in low-lying areas and silently suffocate anything that breathes. In the heart of a lush forest, quicksand lies hidden beneath a carpet of leaves, ready to trap the unsuspecting. Even a peaceful mountain meadow can become the starting point for a sudden avalanche, triggered by the faintest vibration. The plant life in paradise can be just as treacherous. Some of the most vibrant flowers release pollen laced with toxins, while dew-covered leaves conceal carnivorous plants that lure and trap their prey. Mushrooms, seemingly harmless, can release spores that are deadly if inhaled or ingested by animals. Weather, too, can turn paradise into peril. A single bolt of lightning can ignite a wildfire in a sun-baked forest. A sudden flash flood, born from distant storms, can sweep through a canyon with unstoppable force. Dense fog rolling in from the sea can shroud cliffs and ravines, erasing the line between safety and disaster. Scientific studies reveal that these dangers are not random. Volcanoes, for instance, are monitored for seismic activity and gas emissions, yet their eruptions can still catch even the most advanced sensors off guard. Oceanographers have mapped the patterns of undertows and rip currents, showing how they form in seemingly calm waters. Ecologists track the movements of predators in dense jungles, where the rustle of leaves may be the only warning of a lurking threat. Even in the most familiar corners of paradise, danger can hide in plain sight. A beautiful houseplant may contain toxins that can harm animals. Cleaning chemicals, though useful, can react with each other to create hazardous fumes. Moss, thriving in the shade, turns stones into slippery traps after a rain. In the garden, berries that look delicious may be laced with poison, a defense evolved over millennia. Bacteria, invisible to the naked eye, thrive on natural surfaces, waiting for the right conditions to multiply. Fungi, hidden within decaying logs, release spores that can sicken or kill if inhaled by animals. Yet nature also offers lessons in survival. Animals follow ancient trails that avoid danger. Birds build nests in the safest branches, and insects use camouflage to blend into their surroundings, all demonstrating the importance of awareness and adaptation. Science provides us with the tools to understand these hidden hazards. Warning signs mark dangerous trails, guides illustrate which plants to avoid, and diagrams explain how rip currents form, each a reminder that knowledge is the first step to safety. Sometimes the most breathtaking destinations hold the greatest perils, their beauty masking the forces that shape and sometimes threaten life itself. Paradise, it seems, is a place where wonder and danger walk hand in hand. In the end, awareness is the greatest defense. By observing, learning, and respecting the hidden rules of paradise, every creature, great or small, can navigate its wonders safely, turning unseen dangers into opportunities for survival and discovery. Volcanoes are among the most formidable forces shaping the Earth's surface, their presence a testament to the planet's dynamic interior. Deep beneath the crust, immense heat and pressure cause solid rock to melt, forming magma. This molten rock, buoyant and volatile, seeks pathways upward, exploiting fractures and weaknesses in the crust. When the pressure becomes overwhelming, the Earth's surface ruptures, and a volcano is born, unleashing a spectacle of fire, ash, and gas that can transform entire landscapes in moments. These eruptions are not merely destructive, they are also creative, forging new land masses, enriching soils, and even altering global climates through the injection of aerosols and particulates into the atmosphere. Yet the true peril of volcanoes often lies in their hidden mechanisms. Pyroclastic flows, torrents of incandescent gas, ash, and volcanic debris erupt with little warning, surging down slopes at speeds exceeding 700 kilometers per hour. Temperatures within these flows can soar above 1,000 degrees Celsius, vaporizing everything in their path. Unlike the slow advance of lava, pyroclastic flows are swift and silent, their approach masked by darkness or thick clouds of ash. The devastation they leave behind is total, erasing all traces of life and reshaping the land in a matter of seconds. Throughout geological history, these flows have been responsible for some of the most catastrophic events on record. The ancient city of Pompeii was entombed beneath meters of ash and pumice during the eruption of Mount Vesuvius in 79 AD, preserving a moment in time but extinguishing all life within its reach. In 1902, the eruption of Mount Pelée on the island of Martinique unleashed a pyroclastic surge that obliterated the city of Saint-Pierre in minutes, leaving only smouldering ruins as evidence of its existence. Such events underscore the unpredictable and lethal nature of volcanic activity. Another insidious hazard is the lahar, a churning river of volcanic mud, ash, and debris, set in motion by heavy rainfall, melting glaciers, or the eruption itself. Lahars can travel vast distances, following river valleys and engulfing everything in their path. Their consistency ranges from watery flows to thick concrete-like slurries capable of burying entire landscapes. The 1985 eruption of Nevado del Ruiz in Colombia triggered a lahar that swept through the town of Armero, entombing it beneath meters of mud and claiming thousands of lives in a single night. Lahars are unpredictable, their formation dependent on a complex interplay of weather, topography, and volcanic activity. The dangers of volcanoes extend far beyond the immediate blast zone. Volcanic ash, composed of microscopic shards of glass and pulverized rock, can be lofted high into the atmosphere and carried across continents. Among these particles are delicate, hair-like strands of volcanic glass known as Pelé's hair, formed when molten lava is stretched and cooled rapidly by the wind. These fibers are razor-sharp, capable of causing severe respiratory distress and skin irritation if inhaled or touched. The fine ash can infiltrate machinery, contaminate water supplies, and blanket entire regions, disrupting ecosystems and infrastructure alike. Volcanic gases, often invisible and odorless, seep silently from the ground, altering the chemistry of the soil and air. Carbon dioxide, heavier than air, can accumulate in low-lying areas, displacing oxygen and suffocating living organisms. Sulfur dioxide, another common emission, reacts with moisture to form acid rain, which can devastate vegetation and corrode surfaces. The first signs of these changes are often seen in the plant life clinging to volcanic slopes. Lush greenery may suddenly wither and turn brown, a silent warning of toxic gases rising from the depths. To unravel these mysteries and anticipate eruptions, scientists employ a suite of sophisticated tools. Seismic sensors detect the subtle tremors and harmonic vibrations that precede an eruption, while gas analyzers measure the composition and flux of volcanic emissions. Satellites orbiting high above the Earth capture thermal anomalies, ground deformation, and the spread of ash clouds in real time. By integrating these data streams, researchers can construct detailed models of volcanic behavior, offering precious hours or days of warning before an eruption occurs. The reach of a volcano's influence is vast. Ash clouds, propelled by powerful updrafts, can encircle the globe, dimming sunlight and lowering temperatures. The 1815 eruption of Mount Tambora in Indonesia ejected so much ash and sulfur into the stratosphere that it triggered the year without a summer, causing widespread crop failures and climatic anomalies across the northern hemisphere. Even distant regions, seemingly safe from the eruption itself, can suffer the consequences of these atmospheric disturbances. The smallest particles, suspended in the air, pose a persistent threat long after the eruption has subsided. These fine ashes can infiltrate lungs, causing respiratory ailments and aggravating existing health conditions. Water sources become contaminated and the very air becomes hazardous to breathe. In such environments, protective measures such as masks and filtration systems are essential for survival, underscoring the far-reaching impact of volcanic events. The Earth offers subtle warnings before unleashing its volcanic fury. Small tremors ripple through the ground, temperatures rise imperceptibly, and faint plumes of smoke curl from hidden vents. These signs, though easily overlooked, are the planet's way of signaling the immense forces gathering below. In the realm of volcanoes, vigilance and respect for these natural signals are paramount. The mechanisms that drive eruptions are complex and often concealed, but through careful observation and scientific inquiry, the mysteries of these fiery giants continue to be revealed, reminding all that beneath the surface, the Earth is alive, restless, and ever-changing. At first glance, the coastline stretches out in tranquil beauty, soft sand undisturbed, gentle waves lapping at the shore, and a breeze that whispers through the dunes. The rhythmic sound of the surf seems to promise peace, and the horizon glows with the first light of dawn. Yet beneath this serene facade, the coast is a realm of hidden power and unpredictable change, shaped by forces both ancient and immediate. The inviting scenery masks a landscape in constant flux. Tides rise and fall with the pull of the moon, reshaping the shoreline each day. Sandbars form and vanish, currents shift, and the ocean's temperament can change in moments, revealing hazards invisible to the casual observer. Even the sand itself holds secrets. Deep beneath the surface, layers of compacted grains can suddenly give way, creating hidden voids. In rare cases, these collapses are triggered by nothing more than the shifting weight of the earth, swallowing objects or animals whole in a silent, suffocating trap. Scientific studies reveal that sand is a dynamic material, its stability dependent on moisture, grain size, and pressure. In some coastal regions, sudden sand liquefaction has been observed, where solid ground transforms into a fluid state, a phenomenon that can occur without warning. The ocean's surface may appear calm, but beneath, powerful rip currents form as water channeled by breaking waves rushes back to sea. These narrow, fast-moving corridors can reach speeds of up to 8 feet per second, strong enough to drag large debris far from shore in mere moments. Oceanographers have documented rare events where rip currents merge, creating supercurrents that extend hundreds of meters offshore. These invisible rivers of water are responsible for countless unexplained disappearances along otherwise placid beaches. Shorebreak waves formed when deep water swirls meet steeply sloping beaches can unleash tremendous force. In some locations, rogue waves, unexpectedly large and powerful, have been recorded, rising from calm seas to crash ashore with devastating impact, reshaping the coastline in seconds. The coastal shallows are home to creatures both beautiful and deadly. The box jellyfish, nearly invisible in the water, drifts with the currents. Its venom, among the most potent on Earth, can stop a heart in less than 5 minutes. In 2007, a rare bloom of these jellyfish closed entire stretches of coastline in northern Australia, a reminder of nature's unpredictable cycles. Some species of jellyfish are so transparent they are nearly impossible to detect, even in clear water. Marine biologists have discovered that these creatures can travel in massive, drifting swarms, their presence revealed only by the sudden appearance of stings along the shore. The coast is also a stage for rare natural phenomena. In 2011, a sudden meteor tsunami, caused by rapid changes in atmospheric pressure, struck the New Jersey shoreline, sending a 6-foot wave crashing onto the beach under clear skies. Such events, though infrequent, are a testament to the ocean's capacity for surprise. The ocean's beauty is matched only by its unpredictability. Calm waters can conceal the approach of a distant storm, with conditions shifting from serene to violent in minutes. In 2014, a sudden squall off the coast of Cornwall transformed a glassy sea into a maelstrom, catching even seasoned sailors off guard. Along some coasts, bioluminescent algae bloom in the darkness, turning the waves into glowing ribbons of blue. While breathtaking, these blooms can signal harmful changes in water chemistry, sometimes linked to mass die-offs of marine life. So, as twilight falls and the coastline returns to stillness, remember, the calm of the coast is an illusion, shaped by forces both seen and unseen. In this ever-changing border between land and sea, nature's quietest moments often conceal its greatest dangers. Camouflage is nature's secret weapon, allowing countless creatures to vanish in plain sight, an evolutionary marvel honed over millions of years. From the subtle patterns of a snake hidden among grass to the sandy hues of a scorpion melting into the desert, camouflage is a matter of life and death. The eastern copperhead, for example, sports a pattern that mimics fallen leaves, making it nearly invisible to both prey and predators. The Saharan horned viper takes concealment further, burying itself beneath the sand with only its eyes and horns exposed, ready to ambush unsuspecting prey. Even the imposing cassowary, with its dark plumage and secretive habits, can disappear into the rainforest shadows, evading detection by blending with the undergrowth. Its camouflage is not just for hiding, but also for stalking through dense foliage, where sudden movement can startle both rivals and threats. Insects are true masters of disguise. Moths mimic tree bark, stick insects become living twigs, and grasshoppers adopt the colors of their environment, all to avoid detection. Some species, like the orchid mantis, have evolved to resemble flower petals, luring in pollinators, while the leaf-tailed gecko and certain spiders vanish against moss and lichen. Scientists have discovered that animals like chameleons, octopuses, and cuttlefish can actively change their color and even texture using specialized cells called chromatophores and papilla to match their surroundings in real time. In the ocean, leafy sea dragons and pygmy seahorses are nearly indistinguishable from the seaweed and coral they inhabit, while the stonefish lies motionless, perfectly camouflaged on the seafloor. Camouflage is not limited to animals. Plants, too, can mimic stones or dead leaves to avoid herbivores, while some insects and spiders use plant mimicry to ambush prey. In nature's hidden world, survival depends on the art of blending in, an endless arms race of adaptation, deception, and discovery. Camouflage is both a shield and a sword, a testament to the ingenuity of life itself. Our homes may seem like fortresses of safety, but beneath the surface, a host of hidden dangers can threaten our health and well-being. Dust mites, invisible to the naked eye, thrive in bedding and upholstery. Their waste particles are a leading cause of indoor allergies and asthma, triggering immune responses in sensitive individuals. Mold spores, especially from species like Stachybotrys chartarum, can grow undetected behind walls or under floors where moisture accumulates. These spores release mycotoxins, which can cause respiratory issues, headaches, and even neurological symptoms. Older homes may harbor lead-based paint. When this paint deteriorates, it creates toxic dust that, if inhaled or ingested, can cause developmental delays and neurological damage, particularly in children. Corroded plumbing can leach heavy metals like lead and copper into drinking water, posing long-term health risks such as kidney damage and hypertension. Faulty gas lines or appliances can leak colorless, odorless carbon monoxide. Even low-level exposure can cause headaches and dizziness, while high concentrations are fatal within minutes. Asbestos, once common in insulation and flooring, releases microscopic fibers when disturbed. Inhalation of these fibers can lead to lung cancer and mesothelioma, often decades after exposure. Structural threats like termites and carpenter ants silently consume wood, weakening beams and floors. Over time, this can lead to costly repairs or even catastrophic collapse. Unseen pests such as rodents and cockroaches not only spread disease but can also chew through electrical wiring, increasing the risk of fire. Many household cleaning products contain volatile organic compounds and toxic chemicals. Improper storage or mixing can release harmful fumes, causing respiratory distress or chemical burns. Structural cracks and poor drainage allow water intrusion, fostering mold growth and undermining the integrity of the building. Overloaded circuits and damaged wiring are common but overlooked fire hazards, capable of igniting without warning. Radon gas, a radioactive byproduct of soil decay, can seep into basements. Prolonged exposure is the second leading cause of lung cancer after smoking. Bedbugs and fleas, often introduced via used furniture, hide in crevices and fabrics, feeding on blood and causing allergic reactions and skin infections. Vigilant inspection and scientific understanding of these threats are essential for a truly safe home environment. The most dangerous threats are often invisible, but with knowledge and regular checks, we can protect our homes from the inside out. Gardens may look like peaceful sanctuaries, but beneath the leaves and petals, danger often lurks in the form of toxic plants and stealthy animals. Take water hemlock, for example. This innocent-looking plant is one of North America's most poisonous species. Its roots contain toxin, a powerful neurotoxin. In 2010, a group of foragers in Washington state mistook its roots for wild parsnip. Within minutes of tasting it, they suffered violent seizures. One did not survive. Just a tiny bite can be fatal. The castor bean plant is another silent killer. Its seeds contain ricin, a toxin so potent that a single crushed bean can kill an adult. Ricin disrupts protein synthesis at the cellular level, leading to organ failure. In 1978, ricin was infamously used in the assassination of a Bulgarian dissident, highlighting its deadly potential. Giant hogweed, with its towering stalks and umbrella-like flowers, is a botanical menace. Its sap contains furanocoumarins, chemicals that react with sunlight to cause severe burns and blisters. In the UK, a dog brushed against hogweed and suffered painful lesions for weeks. Even a drop of sap in the eyes can cause permanent blindness. In Australia's rainforests, the gympie plant is infamous. Its leaves are covered in silica-tipped hairs that inject a potent neurotoxin. Animals that brush against it can be paralyzed by pain for months. There are stories of horses stung by the plant, throwing themselves off cliffs to escape the agony. Even common stinging nettles can cause intense itching and rashes, thanks to their histamine-filled hairs. Some gardens also harbor venomous spiders or snakes, camouflaged among the greenery, waiting for unsuspecting prey. Nature's beauty often hides real danger. The next time you admire a garden, remember, a little knowledge and caution can mean the difference between a peaceful stroll and a brush with disaster. Science uncovers a world of hidden threats, many of which remain invisible until the moment they strike. Through careful observation and analysis, researchers have identified rare and sudden dangers that can reshape entire environments in seconds. For example, the 2022 Tonga Hunga-Ha-Apai volcanic eruption released energy equivalent to hundreds of atomic bombs, sending shockwaves around the globe. The eruption's ash plume reached the mesosphere, disrupting GPS signals and satellite communications worldwide, a demonstration of how volcanic activity can interfere with global technology infrastructure. Rogue waves, once dismissed as maritime myths, have been confirmed by satellite radar and oceanographic buoys. These waves can exceed 30 meters in height, forming suddenly due to constructive interference of multiple wave systems. In 1995, the Draupner platform in the North Sea recorded a rogue wave, providing the first scientific evidence of their existence and the immense forces they unleash on vessels. A greenish sky is caused by sunlight scattering through water-laden storm clouds. often preceding severe weather like hail or tornadoes. When static electricity builds up in the atmosphere, it can cause hair to stand on end, a precursor to a lightning strike. The electrical field intensifies just before a discharge, making this phenomenon a critical warning of imminent danger. A sudden and dramatic recession of ocean water from the shore is a classic sign of an approaching tsunami, caused by the displacement of massive water volumes after undersea earthquakes or landslides. The 2004 Indian Ocean tsunami demonstrated how this phenomenon can precede waves traveling at jetliner speeds, inundating coastlines with little warning. Nature provides subtle and overt signals, such as seismic tremors, atmospheric pressure drops, and unusual animal behavior that can precede catastrophic events. Early warning systems now use real-time data to detect these changes, issuing alerts that can mitigate disaster impacts. Meteorological instruments, radar, and seismic sensors are essential for interpreting these signs. Detailed case studies show that accurate detection and rapid dissemination of warnings have saved countless lives during hurricanes, earthquakes, and flash floods. The unpredictability of the planet is matched by the complexity of its warning systems. Rare phenomena such as ball lightning, sudden stratospheric warming, and microbursts challenge even the most advanced scientific models. Ongoing research and technological advancements continue to improve understanding of these hazards. Case studies from around the world highlight the importance of scientific vigilance and preparedness. In the realm of sudden danger, survival often depends on the ability to interpret nature's signals and respond with precision. Seemingly innocuous daily routines can harbor significant, sometimes life-threatening risks, as demonstrated by a growing body of scientific research. The act of plucking nose hairs, for example, disrupts the protective mucosal barrier and creates microabrasions. According to clinical studies, this can facilitate the entry of Staphylococcus aureus and other pathogenic bacteria into the bloodstream. In rare but documented cases, such infections have progressed to cavernous sinus thrombosis, a potentially fatal condition due to the proximity of facial veins to the brain. Trimming, rather than plucking, is recommended by otolaryngologists to minimize this risk. Contact lens hygiene is another critical area. Immersing contact lenses in water, including tap or shower water, exposes them to Acanthamoeba and Pseudomonas aeruginosa, microorganisms known to cause severe keratitis and, in extreme cases, irreversible blindness. Epidemiological data from the Centers for Disease Control and Prevention highlight a direct correlation between water exposure and increased incidence of microbial keratitis among lens users. Ophthalmologists universally advise that contact lenses and their cases should never come into contact with water. Only sterile, commercially prepared solutions should be used for cleaning and storage. Consuming beverages directly from unwashed cans introduces another vector for microbial contamination. Studies have detected the presence of pathogenic bacteria, including E. coli and Salmonella, on the surfaces of cans stored in warehouses or transported in unsanitary conditions. Simple interventions, such as wiping or rinsing the can, significantly reduce the microbial load and the risk of gastrointestinal illness. The proliferation of mobile devices has introduced new behavioral hazards. Research published in injury prevention journals documents hundreds of fatalities linked to distracted behaviors, such as taking selfies near hazardous locations. Loss of situational awareness, often termed inattentional blindness, is a well-established cognitive phenomenon that increases the likelihood of accidental injury or death. In response, numerous high-traffic tourist destinations have instituted bans on selfie sticks and implemented physical barriers to mitigate the risk of falls and other accidents. Excessive screen engagement, particularly while navigating public spaces, impairs peripheral awareness and reaction time. Peer-reviewed studies in urban safety have linked this behavior to increased rates of pedestrian injuries and fatalities. Conversely, the adoption of simple safety measures such as fastening seat belts, practicing hand hygiene, and using personal protective equipment has been statistically proven to reduce morbidity and mortality across populations. Behavioral interventions, like consciously setting aside digital devices, foster greater environmental awareness and reduce the likelihood of preventable accidents. Maintaining vigilance in routine environments is as critical as in high-risk settings, according to occupational safety research. In summary, the consistent application of evidence-based safety habits can dramatically decrease the probability of adverse outcomes, underscoring the profound impact of small everyday decisions. Danger can be subtle, lurking in the most beautiful places, from the silent build-up of pressure beneath a volcano to the deceptive calm of ocean waves lapping at the shore or the shifting rocks along coastal cliffs. Even in our gardens and homes, risks are present. Poisonous plants blend in with the greenery, cleaning chemicals sit innocently on shelves, and electrical cords snake across the floor. The world operates by natural laws, not malice, but those laws are indifferent to our presence. Science shows that awareness is our best defense. Animals survive by constantly scanning their environment for threats and opportunities. Psychologists call this situational awareness, the ability to notice and interpret cues like a warning sign on a trail or the sudden shift in wind before a storm. Simple actions like swimming parallel to the shore to escape a rip current or rinsing cans to avoid contamination are rooted in understanding how the world works. In nature and technology alike, preparation is about knowing what to do at the right moment. Machines are programmed to detect anomalies like a sudden change in air quality or a spike in temperature, because these signals can mean danger. Our greatest shield is the ability to notice patterns and respond quickly. Sudden changes in the environment, like a sharp noise, a shift in weather, or a darkening sky, are nature's way of signaling that something is different. Unfamiliar plants, strange patterns in the soil, or the sudden silence of wildlife are all clues. In the wild, survival depends on the ability to observe and act. By staying alert, we not only protect ourselves but also preserve the balance of the world around us. The planet is filled with wonders and hidden risks. With knowledge, curiosity, and constant attention, we can explore and enjoy its beauty safely and for generations to come. As the sun dips below the horizon, a new world awakens, one where danger often wears a cloak of darkness. Nighttime transforms familiar landscapes into arenas of uncertainty, where unseen risks quietly emerge in both wild and urban environments. In the forest, predators like owls and big cats become active. Their senses sharpened by evolution, they rely on silence, shadows, and stealth. An owl's wings are specially adapted to muffle sound, allowing it to swoop down on unsuspecting prey, while the eyes of a leopard are tuned to capture even the faintest glimmer of light. For many animals, night is a time of heightened vulnerability, where every rustle could signal a lurking threat. But the dangers of darkness aren't limited to the wild. In cities, the absence of daylight brings its own hazards. Urban wildlife, like rats and raccoons, emerge to forage, sometimes spreading disease through contaminated surfaces or food. Pools of standing water, invisible in the dark, become breeding grounds for mosquitoes carrying viruses. Even infrastructure poses risks. Unseen potholes, exposed wires, or weakened tree limbs can turn a nighttime stroll into a hazardous journey. Nature itself shifts after sunset. Temperature drops can create sudden fog, reducing visibility and muffling sound. Dew forms on surfaces, making rocks and paths slippery. In deserts, the cold night air can cause rapid drops in body temperature for any creature caught unprepared. Science explains these nocturnal dangers. Many predators possess night vision, echolocation, or heat-sensing abilities, traits that give them the edge when the world is cloaked in black. Meanwhile, prey animals rely on camouflage, quick reflexes, or the safety of numbers, gathering in groups to reduce the odds of being singled out. Even the smallest creatures play a role in the night's hidden threats. Venomous insects and spiders, often inactive by day, roam in search of food. Some plants release toxins or pollen only after dark, creating invisible clouds that can affect the animals nearby. The world after sunset is a complex network of risks and adaptations, a silent chess game played out beneath the stars. Nocturnal life is a testament to the ingenuity of evolution, where every species must find its own way to survive the long dark hours until dawn. By understanding the science behind these silent threats, we gain a deeper appreciation for the unseen struggles that shape life after dark. The night is never truly empty. It's alive with hidden dangers and the remarkable creatures that face them. Beneath the glassy surface of lakes, rivers and ponds lies a world teeming with unseen dangers. Still waters may appear serene, but they conceal hazards that can transform a peaceful habitat into a perilous realm. One of the most insidious threats is toxic algae, microscopic organisms that, under the right conditions, multiply rapidly into harmful blooms. Cyanobacteria, often mistaken for harmless green scum, can release powerful neurotoxins and hepatotoxins. When concentrations spike, these toxins disrupt entire ecosystems, poisoning fish, amphibians, and even birds that come to drink or feed. In Lake Erie, for example, vast blooms have led to mass fish die-offs and the contamination of drinking water supplies, while in Australia's Murray-Darling Basin, toxic algae periodically render entire stretches of river dangerous for all animal life. But the threats in freshwater run deeper. Hidden currents, called undertows or rip currents, can form in seemingly calm rivers and lakes. These powerful flows, generated by changes in water pressure or the movement of submerged obstacles, can sweep small animals like ducklings and aquatic rodents, far from safety in moments. In the Amazon River, the deceptively placid surface can mask swift undercurrents that catch even the most agile swimmers off guard. Rare but formidable, some aquatic predators thrive where least expected. The northern pike, with its lightning-fast strike, preys on everything from frogs to unsuspecting waterbirds. In the rivers of Africa, the Goliath tigerfish, a toothy, muscular hunter, lurks in the shadows, its movements barely disturbing the water above. Even the smallest inhabitants can pose a risk. Parasitic flatworms, like those responsible for schistosomiasis, release larvae into freshwater ponds, infecting snails, and through them, countless amphibians. In some South American lakes, tiny candiru fish are infamous for their parasitic invasions, exploiting the gills of larger fish as a safe haven. Environmental changes amplify these dangers. Rising temperatures and nutrient runoff from surrounding land can trigger larger, more frequent algal blooms. Droughts shrink waterways, concentrating toxins and predators alike, while floods introduce new species and pathogens into fragile aquatic systems. By peering beneath the surface, science uncovers the delicate balance of life and danger, hidden in every drop. Freshwater habitats are not just tranquil retreats, but battlegrounds shaped by adaptation, competition, and survival. In the world of deadly waters, every ripple tells a story of unseen peril, and every creature must navigate a landscape where safety is never guaranteed. In the vast expanse of nature, there exists a realm unseen by the naked eye, a microscopic world teeming with life and danger. This invisible universe is populated by bacteria, viruses, and fungi, each playing a pivotal role in the delicate balance of ecosystems. Yet within this balance, threats emerge, challenging the survival of countless organisms. Bacteria, for instance, are ubiquitous and highly adaptable. These single-celled organisms can be beneficial, aiding in processes like decomposition and nitrogen fixation. However, pathogenic bacteria, such as the causative agent of plague, can decimate populations of rodents and other small mammals. Similarly, responsible for anthrax poses a lethal threat to herbivores grazing in contaminated fields, releasing spores that can persist in the environment for decades. Viruses, though simpler in structure, wield immense power. These tiny entities require a host to replicate, often causing widespread disease. For instance, the ranavirus targets amphibians, leading to mass die-offs in frog populations and disrupting local ecosystems. In the aquatic world, the koi herpes virus can devastate carp populations, altering the dynamics of fish communities and impacting the predators that rely on them. Fungi, too, hold a dual nature. While many fungi form mutualistic relationships with plants, aiding in nutrient absorption, pathogenic fungi can wreak havoc. The chytrid fungus has been implicated in the decline of amphibian species worldwide. This fungus infects the skin of amphibians, impairing their ability to absorb water and electrolytes, often leading to death. These microscopic threats do not act in isolation. Environmental changes such as pollution and climate change can exacerbate their impact. For example, rising temperatures and altered precipitation patterns can enhance the proliferation of harmful bacteria and fungi, while pollution can weaken the immune systems of potential hosts, making them more susceptible to viral infections. The mechanisms by which these microorganisms operate are intricate. Bacteria often produce toxins that damage host tissues, while viruses hijack host cellular machinery to replicate, ultimately destroying the host cells. Fungi, on the other hand, can invade host tissues, disrupting normal physiological functions and triggering immune responses that can be detrimental to the host. In this microscopic battleground, survival is a constant struggle. The interplay between hosts and pathogens drives evolutionary adaptations, shaping the resilience and vulnerability of species. By understanding these invisible threats, we gain insight into the complex web of life that sustains our planet. The invisible world, though hidden from view, is a powerful force in nature. It is a realm where the smallest entities can have the most profound effects, reminding us that in the tapestry of life, every thread, no matter how minute, plays a vital role. Above the surface, the air we breathe may seem pure and life-giving. Yet, hidden within every breath, the atmosphere conceals dangers as potent and as invisible as those found in the microscopic world. Airborne threats come in many forms: toxic gases, microscopic spores, and man-made pollutants, each silently influencing the fate of entire ecosystems. Toxic gases are among the most insidious hazards. In volcanic regions, the sudden release of colorless gases like carbon dioxide or sulfur dioxide can create invisible death zones. One of the most chilling examples occurred in 1986 at Lake Nyos in Cameroon. Without warning, a massive cloud of carbon dioxide erupted from the lake, flowing down into nearby valleys. The gas displaced oxygen, suffocating over 1,700 people and countless animals in minutes. Such events remind us that even the air itself can become a lethal weapon in nature's arsenal. But it's not just geological phenomena that threaten life from above. Fungi release billions of spores into the air, many of which drift for miles, searching for a new host. Some, like the spores of Aspergillus fungi, can cause respiratory illnesses in mammals and birds, especially when immune systems are compromised. For plants, airborne fungal spores, such as those from wheat rust or powdery mildew, can devastate crops, leading to food shortages and economic hardship. Human activities have introduced a new class of airborne threats: environmental pollutants. Industrial emissions, vehicle exhaust, and agricultural chemicals release a cocktail of substances into the atmosphere. Particulate matter, heavy metals, and volatile organic compounds can travel great distances, settling far from their source. Acid rain, formed when sulfur and nitrogen oxides react with moisture in the air, can strip nutrients from soil and poison aquatic habitats. In urban environments, high concentrations of ozone and fine particles are linked to respiratory diseases in wildlife, pets, and even the smallest urban creatures. These threats are often invisible, but not without consequence. Airborne toxins can accumulate in tissues, disrupt hormonal systems, and alter animal behavior. Birds, with their sensitive respiratory systems, are often the first to show signs of distress, acting as living alarms for environmental danger. The science behind these perils is complex. Toxic gases can bind to hemoglobin in the blood, preventing oxygen transport. Spores bypass natural defenses, embedding deep within lungs or plant tissues. Pollutants can trigger inflammation, genetic mutations, and even changes in reproductive patterns. Through all of this, the air remains a battleground, one where the winners and losers are decided by the tiniest particles and the most fleeting gusts of wind. As we unravel the mysteries of these airborne threats, we reveal yet another layer of nature's hidden dangers, reminding us that the very air sustaining life can also be an agent of destruction. Beneath the ground we walk on, an unseen world teems with hazards, silent, patient, and capable of reshaping entire landscapes in moments. While the surface may appear stable, the earth below hosts a complex tapestry of threats, each woven by geological processes and the creatures that call the subsurface home. Sinkholes are among the most dramatic dangers lurking beneath our feet. Formed when water dissolves soluble bedrock such as limestone, gypsum, or salt, vast underground cavities develop over thousands, even millions of years. When the supporting layer grows too thin, the ground above can suddenly collapse, swallowing forests, rivers, and unsuspecting wildlife. The largest sinkholes can reach depths of over 600 meters, exposing ancient strata and trapping entire ecosystems in an instant. These events are not random. Regions with karst topography underlain by easily eroded rock are especially prone to such collapses, their surfaces pockmarked by sudden voids and gaping chasms. But the Earth's dangers are not limited to dramatic collapses. Toxic minerals quietly accumulate in subterranean layers, their presence dictated by chemistry and time. Deep below, deposits of arsenic, mercury, and naturally occurring radioactive materials leach into groundwater, poisoning the roots of plants and the burrows of animals. In some regions, groundwater rising through layers rich in arsenic contaminates entire river systems, affecting the health of aquatic life and terrestrial creatures that rely on these water sources. Minerals such as cinnabar, galena, and uraninite emit slow but persistent radiation or release toxic ions, subtly altering the genetic makeup and behavior of the organisms that dwell nearby. The underground is also a realm of constant movement shaped by the relentless activity of burrowing animals. Earthworms, moles, and insects such as ants and termites engineer vast tunnel networks, transforming the soil's structure. While these activities aerate the earth and aid in nutrient cycling, they can also destabilize roots, create hidden traps, and expose plant communities to disease. Large burrowers like badgers or armadillos carve extensive dens that can undermine entire sections of forest floor, causing unexpected subsidence and shifting habitats for countless species. Even fungi have a role to play. Mycelial networks stretch for kilometers beneath forests, breaking down organic matter and releasing chemicals that can alter soil pH or outcompete plant roots for nutrients. In some cases, toxic molds flourish in the darkness, producing compounds that inhibit growth or prove lethal to competing organisms. Every layer below us is a living archive of hidden perils, constantly shifting, dissolving, and rebuilding. As roots reach downward and creatures delve into the dark, they navigate a labyrinth of physical and chemical hazards. The ground beneath our feet is never truly solid. It is a dynamic frontier where collapse, contamination, and competition shape the fate of life above and below the surface. Above us, the sky may appear calm and predictable, yet the atmosphere is a realm of unseen forces where rare and dangerous weather phenomena can strike without warning, transforming the familiar into the extraordinary in a matter of moments. One of the most powerful yet least understood threats is the microburst. Unlike the sweeping fury of a tornado, a microburst is a concentrated blast of wind, unleashed when a thunderstorm's downdraft accelerates toward the ground. Upon striking the earth, this column of air spreads outward at speeds exceeding 100 miles per hour, flattening trees, overturning vehicles, and scouring the landscape in seconds. Pilots fear microbursts most, as their sudden, unpredictable gusts have brought down aircraft during takeoff and landing. Equally mysterious is ball lightning, a rare glowing sphere of electrical energy that appears during thunderstorms. Witnesses describe orbs the size of grapefruits or basketballs, floating silently through the air, gliding along surfaces or even passing through windows. Scientists believe ball lightning is the result of unique atmospheric conditions, where ionized gases and electromagnetic fields combine to create these short-lived luminous anomalies. Though their existence is fleeting, ball lightning has been known to scorch objects, ignite fires, and leave behind the scent of ozone. Sudden temperature shifts can also unleash hidden dangers. In certain regions, a weather phenomenon called a heat burst occurs when rain-cooled air descends rapidly from high altitudes, warming dramatically as it compresses near the ground. Temperatures can spike by 20 degrees Fahrenheit or more in minutes, wilting crops and disorienting animals. In other cases, rapid drops in temperature, known as cold snaps, can freeze rivers, trap wildlife, and disrupt entire ecosystems overnight. Even rarer are events like ice storms, where supercooled rain coats every surface in a glassy, hazardous sheen, or the eerie green glow that sometimes precedes a severe hailstorm, a warning sign of hailstones forming high above. These unseen forces of weather are reminders that the atmosphere is never truly at rest. Driven by invisible currents, electrical charges, and the delicate balance of heat and moisture, the sky above us conceals a world of rare and unpredictable hazards. Each phenomenon is a testament to the power and complexity of nature, a reminder to respect the forces we cannot always see, but must always be prepared to face. Hidden in plain sight, plants are often seen as the gentle backbone of our ecosystems, providers of oxygen, food, and shelter. Yet, among the lush foliage and vibrant blooms lies a world of lethal power, where survival hinges on chemistry and cunning. Some plants are armed with potent toxins, while others have evolved to consume living prey, blurring the line between flora and fauna. Consider the deadly beauty of the castor bean plant. Its glossy seeds harbor ricin, one of the most toxic natural compounds known. Just a few milligrams can disrupt cellular machinery, halting protein synthesis and leading to organ failure. Similarly, the elegant foxglove, with its tall spires of purple flowers, contains digitalis, a cardiac toxin that can stop a heart in its tracks. These chemical defenses protect the plants from hungry herbivores, ensuring their survival in competitive environments. But toxicity is not their only weapon. Some plants have evolved to become hunters. The Venus flytrap, native to the wetlands of the Carolinas, waits in silence with its jaw-like leaves agape. When an unsuspecting insect triggers its sensory hairs, the trap snaps shut in less than a second, sealing its fate. Enzymes break down the prey, allowing the plant to absorb vital nutrients from its meal. Elsewhere, the pitcher plant lures insects with sweet nectar into its tubular leaves. Once inside, the prey finds itself on a slippery slope, tumbling into a pool of digestive fluids where escape is impossible. In the rainforests of Southeast Asia, the Nepenthes genus has taken this strategy to new extremes. Some species' pitchers are large enough to trap small vertebrates like frogs or even rodents. These adaptations are not just tools of destruction, they are keys to survival in nutrient-poor habitats. By supplementing their diets with animal protein, carnivorous plants thrive where others would wither. Even more insidious are plants like the manchineel tree, found along tropical beaches. Its fruit resembles a harmless apple, but every part of the tree, bark, leaves, sap, is laced with potent toxins. Raindrops falling from its branches can cause blisters on the skin, and standing beneath it during a storm can lead to severe burns. Despite their dangers, these lethal plants play crucial roles in their ecosystems. They regulate insect populations, provide microhabitats for specialized species, and drive the evolution of resistance in animals that dare to feed on them. Their poisons inspire new medicines, and their unique adaptations remind us that the plant kingdom is not always passive. It is a dynamic, sometimes deadly world where every leaf conceals a story of survival. From the forest floor to the wind-swept heath, the lethal power of plants is a testament to nature's inventiveness, a silent, ever-present force shaping life on Earth. In the quiet corners of forests, fields, and even our own homes, a relentless process unfolds, a process that consumes everything, given enough time. This is the world of decay, where the boundaries between life and death blur, and the smallest organisms wield the greatest power. Decomposition is nature's recycling system, breaking down dead organic matter into the building blocks that fuel new life. But while decay is essential for ecosystems, it also harbors hidden dangers. In the wild, fallen trees and animal remains become breeding grounds for fungi and bacteria. These decomposers release enzymes that dismantle complex molecules, turning flesh and wood into rich soil. Yet, not all byproducts of this process are benign. Some fungi, such as the infamous Stachybotrys chartarum, commonly known as black mold, release spores and mycotoxins into the air. Inhaling these particles can trigger allergic reactions, respiratory distress, and even long-term health effects in animals that venture too close. Rot is not limited to the natural world. In built environments, moisture and warmth create ideal conditions for mold to invade walls, ceilings, and floors. Once established, colonies can spread unseen, their microscopic spores infiltrating ventilation systems and contaminating indoor air. Certain molds produce volatile organic compounds, giving rise to the musty odor of damp spaces and, in severe cases, contributing to sick building syndrome. A constellation of symptoms including headaches, fatigue, and difficulty concentrating. Wood, too, is vulnerable. Fungi such as Serpula lacrymans, the dry rot fungus, digest cellulose and lignin, undermining the structural integrity of beams and joists. Left unchecked, these silent destroyers can cause buildings to crumble from within, their presence revealed only by brittle wood and the faint scent of mushrooms. In agricultural settings, decay poses a threat to food security. Spoilage organisms break down crops and stored grains, leading to economic losses, and in some cases, the production of toxins like aflatoxin, a potent carcinogen produced by Aspergillus species. Even the compost heap, a symbol of sustainable recycling, can harbor thermophilic bacteria and molds that release clouds of spores when disturbed. Beneath the surface, the dangers of decay are a reminder that the cycle of life is not always gentle. The agents of rot and mold work tirelessly, dissolving the old to make way for the new. Their activity shapes ecosystems, influences architecture, and challenges our efforts to preserve the things we value. In the dance of decomposition, decay is both a destroyer and a creator, a force that demands respect, vigilance, and understanding. In the world beyond human perception, silence is not a sign of safety. It can be a cloak for danger. Many of nature's most efficient predators move without a sound. Owls, with their uniquely serrated wing feathers, glide through the night air in absolute silence, their prey unaware until it's too late. The snow leopard's padded paws and careful movements allow it to stalk across rocky slopes, invisible and inaudible to its quarry. Even beneath the waves, the octopus slips through coral reefs, its soft body and deliberate motions leaving no trace of its approach. But the threats of silence are not limited to the animal kingdom. In the realm of chemistry and physics, some of the most hazardous forces are those we cannot hear. Colorless, odorless gases like carbon monoxide seep through cracks and crevices, binding to hemoglobin in the blood with an affinity over 200 times greater than oxygen. The result, a silent, invisible threat that can incapacitate or kill without a single warning sound. Methane, another silent gas, accumulates in low-lying spaces, its presence undetectable without specialized sensors. In confined environments, a single spark can trigger catastrophic explosions. Radon, a radioactive gas released from certain soils and rocks, seeps upward into basements and crawl spaces. Prolonged exposure increases the risk of lung cancer in animals that dwell in these subterranean layers. Structural failures, too, often unfold in silence. Deep within a dam, minute cracks propagate through concrete. The process is gradual, almost imperceptible, as stress accumulates until a critical threshold is reached. In forests, the roots of towering trees can be undermined by decay, their stability compromised. The tree may stand tall and seemingly strong, yet the quiet process of rot weakens its core, leaving it vulnerable to collapse without warning. In the silence of the wild and within the engineered spaces of the world, danger often lurks where our senses cannot reach. The threats of silence are a reminder that not all perils announce their arrival. They demand constant vigilance, scientific understanding, and a respect for the unseen forces that shape the fate of every living thing. In the dance between light and darkness, nature weaves a tapestry of hidden hazards. Light, so often a symbol of safety, can become a source of danger when harnessed by the environment in unexpected ways. Blinding reflections, sunlight bouncing off water, ice, or even the glossy leaves of the rainforest can momentarily erase vision, leaving creatures vulnerable to predators or missteps. Snow blindness, a result of ultraviolet rays reflecting off snow, damages delicate retinal cells, rendering animals and their prey alike momentarily sightless in a world of dazzling white. But it is not only the brilliance of light that deceives. The sudden arrival of darkness can plunge the world into uncertainty. In the deep ocean, bioluminescent bursts lure prey into the waiting jaws of predators. On land, the swift onset of nightfall triggers the emergence of nocturnal hunters, their eyes adapted to the faintest glimmers, while their prey is left disoriented and exposed. Bats, for example, exploit the contrast of dusk to hunt insects blinded by the fading sun. Even the interplay of light and shadow creates optical illusions that can spell disaster. The dappled sunlight beneath the forest canopy mimics the patterns of predators, confusing prey and making escape routes uncertain. In deserts, shimmering mirages distort the appearance of water or shelter, leading animals astray. The phenomenon of false bottoms in lakes and rivers, caused by light refracting through layers of water, tricks fish and amphibians into misjudging depth, sometimes with fatal consequences. The science behind these perils lies in the physics of light, reflection, refraction, and absorption. When light strikes a surface, its behavior is dictated by the angle and texture, sometimes scattering in unpredictable ways. In thick fog or heavy rain, light diffuses, erasing familiar landmarks and rendering navigation treacherous. The eyes of many animals, finely tuned to specific wavelengths, can be overwhelmed or fooled by these shifts, with survival hanging in the balance. In the eternal struggle between light and shadow, every living thing must adapt, innovate, or risk succumbing to the unseen dangers cast by the world's ever-changing illumination.